Symposium. Mancini started this back in the mid-90s with his single organic chemistry class. They selected outstanding students from this class to give presentations year after year, and it's grown and evolved into something a little bit larger than that. And when Hank retired a few years ago, three of us kind of took on the role of continuing his good work. Professor Casey Durante, Professor Jenny Weitz, and myself each select two students out of our class to give presentations. So we have 6 student presentations total. They've each researched their own topic. They've each written a full paper on it. In fact, we archive these papers in the library and in the science division, and they'll be presenting their work in a moment. First, though, I'd like to recognize a few people in the audience. I'd like to recognize our District Governing Board President, Dana Sarr. Thank you for coming and supporting our science students. And also our College President, Paul Dale. Thank you for coming. Each has a very busy schedule, and we appreciate them coming to support everybody. Okay, so I know you didn't come here to listen to me talk, so I'll introduce our first speaker. Ms. Megan Reeder, an overview of the foundation of navigation. Please come up.
Hi everyone. So my topic was celestial navigation. Celestial navigation is using objects or celestial bodies in the sky in order to navigate through foreign lands. And navigation was super important back in the ancient civilizations in order to find resources and grow. However, before we had technology and resources, we did not have anything. We had to use our eyes in order to navigate. And ancient civilizations used our eyes to notice patterns in the sky and started to take note of that. One of the first examples of the patterns that they used is the Stonehenge Circle. The Stonehenge Circle is made of stones and pillars that mark the rising and settings of the sun and moon in the sky. This shows impressive notice of the sky and how the civilizations used this in order to navigate. One of the first civilizations to navigate using celestial bodies was the Phoenicians. They were the first to discover the Polaris Star, also known as the North Star. They only traveled, however, along the coast, staying close to land and sight of land, because they did not want to get lost and travel too far away. This did not allow them to travel very far and discover more. The Arabic navigators then began to make inventions and objects in order to help using the sky to travel. This allowed them to travel farther along and discover more. So the first way to navigate was using the sun in the day. They started to notice that the sun rose in the east and set in the west. This allowed them to find direction in the day. They also noticed that as the sun moved throughout the day, they could take note of time, and this allowed them to travel throughout the day. However, they also needed to travel at night. So they started to notice, first they used the sundial disc at the day. The sundial disc was a circle that floated in water, and they would point the disc towards the north or south, and use the length of the shadow to determine their location in the day in the open sea. They would travel at night, and they started to notice the pattern of the stars and the celestial bodies at night. The best star to use was the Polaris Star. The Polaris Star is located at 90 degrees altitude or 90 degrees latitude, and at the equator it's located at 0 degrees altitude or 0 degrees latitude. This was the best way to determine your measurement or your latitude. So the navigator, in the beginning, before they left their position, would take note of what the altitude or the degree of angle was and use this same degree in order to find back where they first start off. The first object they used in order to travel north was the compass. This was invented by the Chinese. They would use the magnetic fields in order to find the north direction. However, the sailors thought this was black magic, so they did not like using this object. So they came up with the kamal. The kamal was invented by the Arabic navigators. It was a cord attached to a wooden piece, and the navigator would tie a knot in the cord so that he held it from his mouth and it held out the wooden piece. The wooden piece would line up with the celestial body at the top and the horizon at the bottom. The next object that they used was the quadrant. The quadrant was similar to the Kamal, and it was a great invention. It was held vertically, and it was divided into 90 intervals. However, it was a lot more difficult to use in the open sea because of the rough current, and they couldn't find accurate readings. So they came up with the astrolabe. The astrolabe was a lot better, and it was the best way to determine latitude. It was held freely by the navigator, and so that the light from the celestial body would fall through the object. The navigator moved the aladad, which was a piece on the object, so that the light would fall through the top hole and through the bottom hole, and this will cause you to allow to measure the angle and your direction. The next object they used was the cross staff, which looked like a T. They would point the stick towards the sky and move the top of the T so that the object, or the sun, was at the top and the horizon was at the bottom. This was very dangerous to use and caused a lot of blindness in the sailors because they're constantly staring at the sun. So they came up with the backstaff. The backstaff allowed the user to face away from the object and measure their angle. However, they could not use this at night because it was difficult to see the stars from behind them, so they came up with prisms using mirrors. The first object they used was the sextant. The sextant is a two-mirror device that causes a reflection. They would point the first part towards the horizon and use the second mirror to reflect the sun. So you can see that the navigator would point the eyepiece toward the horizon and then move the bottom piece so that the sun would move the mirror towards the sun at the bottom of the horizon, and this would allow you to measure your degree of angle, and this caused them to find the latitude a lot better than the other instruments. However, once they had latitude, they didn't find longitude, which was a lot more difficult to discover. Sailors would use dead reckoning, which was pretty much just guessing where they were along the coast, and caused a lot of the sailors to crash into the coast, which was not safe. So they started measuring lunar distances, which is measuring from the star to the sun, which would decrease as the moon would set, and they would use this compared to time. So the Earth rotates at 360 degrees per day, and which is 15 degrees per hour. And at the Greenwich meridian, it's at 0 degrees. So if they knew their position from this Greenwich meridian and compared it from the distance of the lunar distance, they could know their longitude. However, time was very difficult to find out because it was very inaccurate. It could take hours to find out, so they came up with the chronometer. The chronometer was the best way to find time. The sailor would use this and compare it to the time they used from the lunar distance and the chronometer, and they would find their longitude. And once they had their latitude and longitude, they were able to navigate much better with more precision and change the way civilizations traveled. Thank you.
Pretty much pinpoint you to within.
Yeah.
So, what do you think, or could you guess what the accuracy of these measurements would give you? Within a few miles?
The objects that they used, it was a lot more difficult. This was a very simple way of explaining it. They had to know like really tough math. They had to sit there with all their sheets and sit there for hours, and they would use it. So it could be off a lot more, but they had to sit there for a long time to know where they actually were going. It was a lot more difficult than these objects allowed them to use it better, but they had to sit there with paperwork and all their maps and stuff to figure it out. It took them a long time. Any other questions?